The planar vestibular dynamic inclinometer is a non-contact inclination sensor motivated by the human vestibular system. It measures the inclination parameters for 5 degrees of freedom robot. Motivated by the human vestibular system and the symmetrical placement of the human ears, the sensor design consists of 4 symmetrically placed dual-axis accelerometers and 1 tri-axial gyroscope. Here L1R1 and L2R2 denote the pairs of symmetrically placed dual-axis accelerometers about point P. The hollow arrows indicate the sensitive axes for the accelerometers. G denotes the tri-axial gyroscope. It is assumed that 1-2 Euler rotations align the robot to the equilibrium axis, which is the vertical. The 1-2 Euler angles are denoted by theta and psi, as indicated. The experimental setup consisted of MEMS gyroscope and symmetrically placed MEMS accelerometers as shown. Magnetic encoders are fixed at the joints for the purpose of comparison. In this experiment, we move the inverted pendulum and compare the Euler inclination angles, theta and psi, obtained from the planar vestibular dynamic inclinometer to the angles measured from the magnetic encoders. The inclination measurements are valid for environments with varying gravity and accelerating platforms. The sensor outputs are ideal control inputs for balancing robots. Some advantages of the sensor include low computation cost, inclination angle is measured, not estimated, the measurements are valid for large angles, the reference of the dynamic inclination is the dynamic equilibrium axis.